Hi friends, today I will show you how to create a linked list dynamically using pointer and perform different operations like insert node at head, insert at tail, delete at head, and delete at tail. Many students think that creation of linked list is a complicated process. But once got the conception, he can write C or C++ program very easily to create a linked list. Now I will show you in the presentation how different operations like insertion at head, insertion at tail, etc. take place in a linked list. Initially, when there is no node in the linked list, how the first node is created. First node is created using the syntax ptr equal new node. Ptr is the pointer variable. We are inserting info s5 in the data part of the node. Now pointing the link part of the node to null, as well as positioning the head at this node. Now ptr and head both the pointers same for the first node. Now we'll go for the second node. That means how insertion will take place for the second node. After creation of the first node, how second node is created. This is the first node already there in the linked list. Now we will create the second node with info 7 using the syntax ptr equal new node. Now this node is created. Now the next part of the second node will point to the first node, and we will move the head from the first node to the second node. Now the second node will be the head of the linked list. Now how it take place? Now pointing the next part of the second node to the first node. Now we are positioning the head of the linked list with the second node. This is how the insertion take place. Now I will show you how insertion take place at tail. Initially, when there is no need in the linked list, the procedure is same with the insertion at head. We are creating a node with info 5 and pointing the link part of the node to null and positioning the head with the pointer. Now, after creation of the first node, how we will create the second one? This is the first node with info 5. Now we will create the second node. We should remember that we should not disturb the head of the linked list. If we want to do any operation, we should use another pointer like cp current pointer that I am using in this presentation. We will not disturb the head. We will use the cp. And now suppose I have created one node with info 7. Now I will point the next part of the node to null. It's pointing to null. Now we'll have to move the next part of the first node to the current node, since we are inserting at tail. So how it take place? This is the ptr. Now it is the next part of the first node is pointing to the second node. Now head will remain same. Now we are moving the cp using the syntax CP equal PTR. Now we have seen here mainly 2 pointers, one head, that is head of the linked list, and one current pointer, so that we can move to the next node. Now how we can display the linked list? Our aim is we'll visit each and every node and we'll display the info part of the linked list. For this purpose, how we will use? The head is the starting point for to display the info part of the linked list. We'll use one current pointer here. Now we'll move the current pointer from head to towards the last node. How it take place? CP is in the first node, will display, then it will move to second node, and it is moving to third node, then the fourth node, then fifth node. What condition you will have to specify at the time of moving the current pointer? While CP is not null, we can see here 3.3. Now I will show you how deletion can be done at head and at tail. What procedure will follow for deletion of the node at head? Suppose this is the existing linked list having 5 nodes within 4, 5, 6, 7, 8 and 9. We can see here the link part of the last node is pointing to null. This is the head of the linked list. For deletion at head, we'll create one pointer, that is del node, and we'll position with the head node so that we can delete the node at head without disturbing the original head of the linked list. See how it takes place. First, our aim is, first we will move the head from the first node to the immediate second node. Now this is the head of the linked list. Now we will disconnect the del node from the existing linked list so that we can delete from the original linked list. How we will disconnect it? Just we will point the next part of the del node to null. Now this node has been disconnected from the existing linked list. Now we will delete the del node from the list. It is deleted. That's how we can delete at node. Now how we can delete a node at tail? It is a bit tricky process. For this one, we'll have to consider two pointer so that we can move from head to the last node. Suppose there is a linked list having 5 info 5, 6, 7, 8, 9. The next part of the last node is pointing null. Now we will create two pointer CP and DP. We will move the CP to the last node from head to the last node. Now CP is pointing just before the last node. Now we are moving the DP delete pointer, that means we are moving to the last node. Now we can see here CP is pointing at this node and DP is pointing to the last node. Now we will disconnect the last node from the linked list. How we will do this one? We will point the next part of the CP node to the null. See, this node has been disconnected from the original linked list. Now we will delete the DP from the linked list. The syntax for deletion of the pointer is delete dp. We can see here. Now this node has been deleted from the linked list. We can see here the source code of the linked list. I'm using the syntax of the C++. These are the 5 function I've declared here as prototype. This is the structure, name of the structure node. I have declared here many pointer like head, ptr, cp, current pointer, that is del node, hlp, that is help, that means it will help like for displaying the info part of the linked list, etc. This is the main menu. You can see here the complete source program. You can download the source program from the website dumblaconsultancy.wordpress.com. This is the insertion at head function. This is insertion at tail. This is the whole program. Now I will execute the program. See, I'm using here 6 options, 1 2 3 4 5 6. Suppose I want to insert a head, I will enter 1. Suppose I am inserting 10. You can display the linked list, that is option 5. This is 10. Now I will insert a tail, that is option 2. Suppose 20. Suppose 10 20. Now again insert at head 1. Suppose I am inserting 50 at head 5. Again will insert at tail, suppose 2. Suppose 90 5. Thus we can execute the linked list. Suppose I want to delete a tail, this is option 3. 90 is deleted. Now display the linked list. Now we'll delete at head, that is option 4, by using 4. 50 deleted from the linked list.